Just waiting for the stream to come on. This is the usual thing. Wait for the green light to go. I think that's working. Yes, I think that's working. Hello, 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 hello. Good evening. It is getting very dark these days in England here. So I've actually got a softbox light in this office, and we've also got some poles, if you can see. I was doing some green screen work. I was creating a programming course recently, and there the polls, the green screen goes off. Anyway, I'm going off on a massive tangent. Hello, my name's Peter Fisher, and today we're going to be talking about restructuring versus refactoring when building a web application. And we're going to sort of talk about it from many different perspectives, both design as well as coding as well. So it's not just about programming, it's also about design when you're restructuring and refactoring things. So that's the topic we're going to be talking about today. Before I start, though, I just want to say a massive thank you and a welcome to all the new subscribers to both the channel here on YouTube as well as Facebook, Twitter, Instagram, and all of those places where I push all the content. Hello and welcome. If you're not subscribed, then do consider doing so, because on Tuesday, well, basically we have 3 videos a week. On the Tuesday, we do a tutorial, and that tutorial covers, recently it's been covering Python control structures. We're moving into some AWS stuff. I've also got a whole bunch of other courses, so do check out the channel as well as the howtocodewell.net website. Wednesday, which is today, we do a live stream where I pick a particular topic that I wish to discuss, and we have a to and from conversation. As I said, today is going to be about restructuring and refactoring. And then on the Fridays, we do it's kind of like a pre-recorded show that I've done that I do on the Friday. So there's 3 videos a week. I am a freelance web and mobile applications developer, so I do this in my spare time. I'm very passionate about teaching people and sharing knowledge, and hence the whole channel. So if you are any particular programmer, any particular web developer, it doesn't matter if you're a Python dev or a JavaScript dev, or if you're front end or back end, do consider subscribing, and hopefully you'll learn something. So in these streams, I also talk about what I get up to on a weekly basis as a freelance developer. And this week has been incredibly busy. There's been a lot of fixing of bugs. There's been a lot of sort of administration type stuff of recording bugs and going through user journeys, that kind of thing, on various projects. And it's been one of those mixed bags weeks. Sometimes I was using CSS. I did a bit of at the start of the week. I did a bit of Sass, a bit of creation of CSS variables, and all of that lovely stuff, just tweaking changes here and there. I also did a fair bit of JavaScript as well, to do with some Ajax-y kind of work. And I also did a massive piece of work around some refactoring, which is kind of spurring off this talk that I'm going to do. It was refactoring stroke restructuring. And I suppose really we should start with coding is one of those it's a technical thing, and therefore we should be able to talk about it in a very carefully thought out way. It is a technical thing. Technical things usually are extremely well defined, and therefore the terminology and the language that we use to talk about those things needs to be correct. And I got myself in, I had a conversation with a developer at the start of this week, and unfortunately I was using the wrong terminology to explain the things that I had done. It was a large piece of work to do with putting in a new layer into the code that handles caching and memory type stuff. So it's a lot of sort of fiddly work that I was doing at the back end of last week, early this week. And I was talking about it from the approach of the amount of code that I was refactoring in order to get this thing in. And actually, what I should have been saying is I was restructuring the system in order to add this layer. And that's the distinction, the definition between restructuring and refactoring is that you, as a coder, are changing the behavior of the application. So if you change the behavior, if you add features and functionality, and I'm not just talking about features and functionality from a client or a customer, it's not just like adding a new sort of page or something, or a new way of doing an API call or what have you. I'm talking about a feature that is perhaps a new caching layer like I added, or a new database layer, or a new way of doing some computation, some sort of calculation. When you're changing the path of a program, that is a restructure in that sense. You are rebuilding the behavior of the system, whereas a refactor is smaller than a restructure, because a refactor is more about altering the way the code becomes more readable and maintainable, and we'll be talking about all of those kind of things later on in this talk about the benefits of refactoring. So what I was doing was both refactoring and restructuring, because obviously when I changed the structure of the application and I put in this new layer that hadn't existed before, I then had to refactor the existing code to then adhere to that new layer. And that, as I said, is the difference here. But we can talk about the restructuring versus refactoring outside of programming. We can talk about it in design. So, for example, if you're a designer, you're a web designer, and you are building upon an application that is already in existence, so you've already got a design. When you are restructuring that design, you are altering the way in which the user behaves, or the user journey. So you might be adding a page, or you might be putting in a page between a page. You might be adding some features and some functionality that the user can do that never existed before. You might also be removing that functionality as well. Whereas a refactor of design is more to do with refactoring how an existing thing looks. So, for instance, you might have all of the call to actions on that page, but you might be changing the way they look. You might be changing the way they are upon the page. Now, that is a gray area between a restructure and refactor, because when you're refactoring something, you are also restructuring things, but you are restructuring things that already exist, as in you aren't adding or subtracting any new functionality, any new logical thing. You are simply altering how something is to be easier for it in the future, to be maintainable, to be extendable, and so on and so forth. So in the example of a design, you might be changing the color, the positioning of a button for refactoring, whereas a restructure would be, you might be adding an additional page inside a user journey to change the structure of the user behavior. With an application, when you're with a code, if you use that idea with code, you are therefore adding or subtracting pieces of functionality from the code. And again, it's not always the functionality of a client's needs and requirements off of a PRD, a project requirements document. It could be just adding a different way of calculating, or adding calculation to that, or adding different layers, say caching layers or database layers, or changing the way the data is called from different things. You might be using, one minute you could be using GraphQL, next minute you could just be using MongoDB. That is a change of the structure of your application. The refactor, however, is more smaller. Like I said, it's all about changing the way the code reads and the code, I don't want to say behaves, but how the code can be extendable in the future. There is an element of restructuring when you're refactoring, of course, but it isn't as brutal as let's just crowbar in, or not crowbar in, let's just add this new layer between these layers of functionality in the code. So let's just put restructuring to one side for now, and let's just focus on refactoring, because this is the thing that, I mean, everybody says, let's just refactor code, and, but what is refactoring of code? What I've said, it changes the way things are to be more readable, but what does that really mean? Because there's lots of stuff that comes under that umbrella of just readable code. I did a talk, I did a live stream not so long ago, a couple of weeks ago, about clean code. Clean code comes into refactoring when you're making the code cleaner for you and other developers to use. You need to think of it like reading a book and giving the other developers the opportunity to add chapters into that book. You need to have some sort of common standards. So, as an example, I did this thing about caching, and I unfortunately I used the words refactoring more than restructuring. It turns out that there was actually an awful lot of restructuring that went on in order to get this caching layer through. Now, one thing that this caching layer required was a way of creating a key. So we were using memcache, and memcache is a key value pair. It's just strings. So the key is a string and the value is a string. So things were being serialized in memcache. And I was creating a series of helpers that would allow me to create the cache key, the key that denotes, it should be a unique key for every single cached item in the memcache pool. And I created some functionality that allowed simple injection of properties and parameters into a method that generated this cache key, because I didn't want to have to manually type out this cache key. You want to try and reduce the amount of manual work when you've got thousands of database calls. You want to have, and you want to be able to conform to a certain standard. So that went through a whole series of refactoring, where I was injecting certain properties based on maybe requests. So it was using the PSR request, and that was getting the values out of that request object. Depending on certain requests, these things would go at the start of the key, or they would go in the middle of the key, and so on and so forth. Then I discovered that memcache has a limit to the character size of the key, and therefore I had to go back and reevaluate the conventions, the naming conventions for these things, to ensure that they were both small enough to fit and have enough room for future growth, but also readable for the human, so they can identify which cache key they are actually working upon. So there was a lot of refactoring there, and there was a lot of changing of the parameters and changing of the way things were called. So, for example, the actual thing that created this cache key was called generate, but then I decided to just create that as a class in a class and just call that create. So now I've got cache key as the class and then create. It's similar to generate, but it's easier, it's smaller, so it's create. And also that is the same naming conventions that this project has in order to create things. You're not generating things. In actual fact, the first thing it was called was get. And get didn't really make any sense because get implies that that thing already exists. And of course, it didn't exist. It needed to generate. And therefore, I created the generate. And then generate was just too long and didn't have the same convention as everything else. So I just chose create. So it's easier for the user, the developer, to understand. Yes, it's a creation thing. So I need to supply it some parameters, and it's going to come back with something else. Whereas when you're getting something, you are implying that it already is in existence. So naming things is important, and also detecting code smells. So detecting things that will just make your code really ugly, unreadable. So for instance, one of the things that I've been doing was reducing the amount of street furniture within the methods and within the classes. So for instance, if a method was doing more than two things, then in my opinion that needed to be split out and refactored. And in some cases, they actually turned out to be smaller utility classes that I could some of them could even be called statically into the thing. And yes, they were doing very small things, but you could sort of almost pipe the input and output to other processes. So it became a little bit more modular, a little tighter, a little bit more easier to read. And one thing is like if statements. If you've got a ton of if statements in your function or your method, then that is a sign to refactor, because you should be writing the actual definition of that method or that function as the function name, and it should only be doing that thing. And if you're having, say, 4 or 5 different if statements in a function or a method, then that is doing 4 or 5 different checks, different things, and that could be sort of refactored and altered and changed. You're not changing the behavior, you're not changing the flow of the program, you're just changing what is being called at what time in order to get you the same result. That is the point of refactoring. The result doesn't change. The thing that you actually show your client and your customer doesn't change. It is how the program is read by us developers that changes, that becomes more easier to read. And you do these micro refactors, right? You do these smaller micro refactors, and one needs to get used to doing this as developers. We shouldn't just go, yes, this works, this bug is fixed, and I will not look at this code ever again, I'm going to work on another bug. We should be re-evaluating our code and just seeing if there are anything that we can do to make it easier to read and easier to maintain. Not only are you creating it easier for readability, but you're also creating it as easier for extendability. Because when you're creating something that is cleaner to use, you are also creating something that is cleaner to update and improve. And you are perhaps creating it in a pluggable way, so you can now snap things onto that application that you've built in an easier way, in an easier fashion. And also, because it is easier to read and easier to maintain, one would hope that it's not. One would hope that it's easier to test as well. So another problem I had this week was I created something to do with the caching, and I tested it on several sort of staging places. One was where the caching was turned on, and one was where the caching was turned off. I discovered that there was an issue with the way in which the cache keys were generated, and I was getting stale cache. That is just a massive no-no when working with caching. Stale cache is just horrible. So what I discovered, it was a problem with the way in which the cache keys were being generated. And I needed to test that way of generation for that particular use case. And I found that incredibly difficult because the way in which I had injected that in, or I coupled that to the classes, or the way the cache generation was in its own class, and I coupled that to other classes, and it just got very, very messy. In order for me to write a proper test, I had to do a series of unit test mocks to mock that out. And I ended up, well, if you're mocking lots of stuff, then that is, in my opinion, a warning sign that your code isn't structured very well. It's not, it doesn't adhere to good design principles and practices. So what I ended up doing was altering the structure of the way in which the cache key generation was injected into whatever I was doing. So there I was changing the structure. I was changing the structure of how that cache generation class was being injected. However, I wasn't changing how the program behaved. I was just changing where things were being called, which meant that it became much more decoupled, which meant that I could test that cache generation, that cache key generator in isolation, which is what you want to do when you're unit testing. You don't want to unit test something and then have to instantiate a whole bunch of other stuff just to test this one little unit, because you're having to couple all sorts of things together, and that is just a bad place to be. So if you're finding it very difficult to test, that's usually a warning sign that your code needs to be refactored. Not necessarily altering the functions and the features of your code. It's just the code is difficult to test in isolation. Bear with me a moment. I'm just going to grab some tea. So other code smells that I'm going to talk about are where the method names are just too long. So that the method names don't marry up to what the method is doing. And there is a debate as to whether or not the method name or the function name, it doesn't have to be object orientated, it could be a function name, whether that should describe what is being returned, or that should describe what you need to give it. So for example, if you're doing a call to a database, have you got a method name that is that describes what is being returned, or have you got a method name to describe how to get something using a set of parameters? So for example, find by means that you're finding by something. So if you do find by ID, order by last name, that's a humongous method name. However, it explains exactly what that is that will achieve. But you could go longer and longer and longer and longer, because you're having to inject all sorts of parameters into this thing. And if it becomes too long because you are trying to explain every little thing that method does, that's highlighting that method is doing too much. Not only that, but also variable names as well. So if your variable names are too long, if you're having to sort of camel case everything, and then that means that variable isn't well defined. So I go back to this whole, you need to be, your language that you use to not only explain your application, but the language you use in the application needs to be well defined. And naming things is one of the awful things that we have to do. It's so difficult to name something and actually pin down what something actually does and means, because you can look upon a variable name or a method name in many different ways and in many different contexts. Another thing is where your classes are just huge. So I've talked before about having a God class, where the class has so many different responsibilities that the name of the class just no longer does it any justice. So the class needs to be exactly what, or should only do exactly sort of its own set of responsibilities. If you can define a series of additional responsibilities within a class, then those responsibilities should be in another class. And you could go the other way with this. You could make things so small. I was asked a question on one of my previous live streams about does clean code just mean smaller code, modular code? Well, no, it doesn't, because you could go really small and have like just a couple of methods within a class, but you could have hundreds of classes, thousands of classes, and they could all be doing the same thing, but in a very different way. So they could all be doing similar bits and pieces. And so what you could be doing instead is maybe using some polymorphism or some better encapsulation to handle those kind of eventualities. You might think to look at some factory classes as a way of generating, instantiating those objects that are returned, instead of having humongous amounts of classes dotted all over the place that do a similar thing. That also means that your inheritance is wrong, because perhaps all of those many classes could be condensed down into a base class. And that's another point that I want to make. There's this thing called pushing down. So that's where you're putting methods into base classes that you are extending from, which means that other classes can then extend from that, which gives them the functionality. Just be careful though, because you might have your concrete classes as nice and clean, but your base classes could be the God class. So just be careful with that. Also, having loads of interfaces all over the place that don't necessarily do a lot of stuff. They're just there because of a convenience factor, rather than they actually have any kind of impact on the application. So you've got to be careful that going small too much, it may be a code smell. And basically you want to look upon this process of refactoring code as a way of making things better for you and other developers, and try and have some goals. So let's say, for example, you want to reduce the code by a certain amount of lines, then that could be a goal. Although be very careful with that, because the more you remove, you might be removing some ways of decoupling. So be careful. But I have heard people have goals for refactoring where they have like a set amount of lines per function or per method or per class that they would like to keep to under that. But be careful. Also, the whole don't repeat yourself, so dry. So if you've got any code that kind of does the same thing, then that again is a code smell. That is something that you need to remove. And you could probably do something similar in polymorphism. You could probably do something similar by just tweaking the parameters. And whilst I talk about parameters, one project that I've dealt with recently, there was like a method that had like 25 parameters in it, and that's just insane. You're having to inject 25 things into your method in order for your method to run. That was a massive code smell, and unfortunately that was very wide reaching, which took a lot of time to unpick and debug. But it's now far easier to manage and maintain and to use. So I've talked about encapsulating. So encapsulating the logic or the values within classes. This can be a bad thing sometimes, because you are basically forcing yourself to create a set of accessor methods, so getters and setters, and you might eventually just end up with classes that are just full of getters and setters, which means that your code is actually quite long, but it does follow a similar convention, so it is a bit of a toss-up. And also, when you've, like I said, the massive amount of if statements, massive amount of switch statements, you might as well just use some polymorphism for that, which is all good. And the other techniques of, well, I said pushing down. There's also pushing up, so moving code up a level in inheritance to make it a little bit more user in sort of super classes as well. That's a good thing. And it's just basically a way of re-evaluating your code and making your code easier to deal with. Bear with me. Refactoring also could be as simple as just renaming a file, because that file might not be in the same naming convention as other things. It could also just be as simple as renaming a class as well. It could be as simple as using abstract classes and forcing other classes to adhere to some principles and some designs. So reevaluate your designs within your code. Reevaluate how you are using design patterns. Maybe there is a design pattern that you're unaware of that could do what you're trying to do far easier, far quicker, and far better. And this is something that just comes with practice. This is something that everybody does. Everybody has to just sort of look at their code and see if there is a way of making it better and more efficient. And I don't mean efficient in terms of speed. I mean efficient in terms of just, working with it. Because it's lovely when code becomes snappy, when code just snaps together. And when you go and get another feature, maybe your client comes to you with another feature, and you are able to build that very, very quickly because you've already refactored the foundations of the software, which allows you to snap that in a very plug-inable manner. So there are ways you can do this in an automated way. So I use Phpstorm. At the moment, I've used NetBeans before. They both have a way of refactoring code where you can do like on a context menu, right click and then refactor, and then choose what it is that you wish to refactor. There's also ways of refactoring things in JavaScript as well. So it isn't just PHP or Python. It isn't just backend stuff. It's also refactoring the front end as well. So refactoring your promises, refactoring how your event listeners are, all of that kind of stuff. Basically, if you look at code and you just can't read it, you can't understand it at a glance, then there is something that you need to do in order to make that readable. And it isn't just a case of, well, I don't understand this, I'm not a good enough developer to understand it. If it just doesn't explain what you should be doing or what it's doing, then that is unreadable. So I go back to this whole, my cache method was, first of all, it was called get, and then it was called generate, and then it was called create. Well, it's gone through those 3 iterations, those micro refactoring, and now because it's called create, it just does exactly what it says on the tin. It creates and returns what it's created. It's not generating anything because it's not having to, well, it is generating, but the word generate is quite long. And it's certainly not getting anything because there isn't anything yet to get. You are injecting the parameters for it to then create this cache key, this string, following a series of conventions, naming conventions and other bits and pieces, and then returning that after it's been created. So there's lots of ways that one can refactor code, and they can do it extremely simply. There's also ways of doing this in sort of a peer programming type way. I don't know if anybody has done peer programming, where you write a line of code or you write a function and then the other programmer does their bit, and then you kind of evaluate both of your pieces of code. A lot of people have different coding styles. That's very interesting. It's a very interesting way of learning and adapting to how one should write code for others to read. I think that is very important. Gosh, sorry guys, my throat is extremely dry today. I think it doesn't help that I've got this massive softbox beaming light into my eyes. I'm just going through my notes here. So I've mentioned about extendability. I've mentioned about unit testing and how refactoring code should help you to refactor, and how testing can be a indicator of how you should be refactoring your code if your code isn't easily tested. I've kind of talked about code sharing in the sense of in the sense of abstract classes and all of that. There's also generalizing your code, so not perhaps making it a little bit more abstract, a little bit more usable for other things. One project that I've done before was it was on a particular framework which was custom built, but the actual application was completely different. It created several applications and all were completely different, and yet the code from the ground level was totally the same. It was done in a way that was so abstract, not overly top abstract either, just abstract, and it allowed you to do different things and put on different front ends against the back end that was extremely easy to do. There's also refactoring of URLs, refactoring of APIs. There's also refactoring of the responses of those APIs as well. So having refactoring the way in which you call the API, so the endpoint of that API. So, for example, one thing that I did recently was created a bunch of API calls to list out certain things, certain things from an external data store, and it turned out that there was a lot of APIs that were extremely the same, and however they were called slightly differently. And it turned out that actually it would be easier to change the way those API calls were actually being accessed, the URLs of those API calls, to follow a convention, which meant that the next API call that was being built had a template in order to follow. Same with the response. So with the API calls that had a level of pagination, so it came back with a page number, total records, that kind of thing, to keep that in to come up with a standard way of doing that, that other API calls could adhere to. And in the back end, we created some helper classes to generate all of those things. So it became extremely easy for another developer to then write the same API call, but off of the back of different data structures. And that's basically it. Really, it just allowed us to become better and quicker. And this is something as a freelancer. This is a point that I want to make, because a lot of clients they'll only see the output. They'll only see the end result, right? They don't have a big appreciation for what actually is involved in the code. And also, quite rightly, they won't understand the need of reevaluating a project, a feature's code after the feature has gone live, from a technical point of view. They'll obviously understand how to do it from a user's point of view, from a business point of view. Let's see if we can try and alter this feature to get more users subscribing. Let's see if we can alter this feature so we can upsell products, that kind of thing, but not from a technical point of view, not from I've written this piece of code, let's see if I can make this a little bit easier to read and maintain for the future things. And so they don't necessarily have that level of appreciation, and it is a bit awkward when you are trying to explain how one needs to refactor code in order to make it better. And this is unfortunately a driver of legacy code, where a programmer comes in and they don't necessarily take a look under the bonnet of the stuff that is already there. So they either go off and make their own stuff, not realizing that something is already in place, that they could call upon to do that, or they realize that in order to make the code clean for what they're doing, they would then have to alter the code that was already being made, and that's an awkward conversation, because you're coming back to the client with, yeah, well, I could do it like this, but it's going to take a longer to do, but in the long term, for you, it's going to be brilliant, because it's going to allow not only me but other developers on board to make better, quicker, easier changes. So it's the distinction there of thinking on a long term rather than it's a short term, because quite rightly, when people want a feature in a website, they want it quite quickly, and that's just the part of the parcel, part of the conversation that freelancers have, and other developers as well. I mean, it's not just freelance, but when you're working with some sort of product owner who isn't technically minded, then there is a level of education that is needed to bring them on board to the changes of existing code before you actually get to the point of adding new features. And unfortunately, if that conversation hasn't happened, then you're going to end up having all sorts of legacy code upon legacy code upon legacy code, where a programmer has just worked in isolation on something and either hasn't appreciated what is already there, so they go and reinvent the wheel, or they get scared that something needs to be changed quite drastically in order for them to make something nice and simple. And so they end up just bolting on something that they've got, that they've just created, reinventing the wheel and all of that stuff. That is the opposite of refactoring, because when you're reinventing the wheel, you are creating something that is similar to what already exists. And one of the points of refactoring is that you shouldn't repeat yourself. Not only shouldn't you repeat yourself in the feature kind of way, but in the code kind of way. So if you've got two functions and they're doing the similar thing and they're returning a similar thing, then maybe that should just be one function. If you've got functions that are returning the same thing, called differently, have different inputs, then that is another issue as well, because you've got two pieces of functionality that are doing extremely similar bits and pieces, and that's two pieces of code to maintain. So when you go about reducing code and making code smaller and cleaner, you're giving yourself some breathing space for maintenance in the future. And again, this is a point from a freelancer's point of view, is that removing code is great, because when you're removing code and you're running the test and it tests and it still works, that means you're removing technical debt. You're removing technical debt that you no longer have to deal with. You're removing something that you no longer have to maintain. And you can write that code in an easier, more succinct sort of method or function. Now, I've used a lot of things today about object-oriented programming. I've talked about design patterns. I've talked about encapsulation and polymorphism, but refactoring really isn't just for object-oriented programming. I even started this talk on just graphic design, restructuring and refactoring web design. So it isn't just object-oriented programming. There is so many things that you can refactor in just a functional scripted language. And don't forget, it's not just the program, it's also the configuration of that program too. You might want to refactor how the configuration works. You might want to refactor all the configuration keys to adhere to a simplified way of doing things. You might want to change your YAML scripts to have objects or arrays, or you might want to change how certain classes are injected into the Symfony, your Symfony services. All of those things will make your code easier to maintain and read in the future. So let's just check the time. It's 45 minutes, so I'm going to answer some questions. So if you've got any questions, just let me know. DIY Coders has said, do you recommend PHP WordPress or PHP October CMS? Okay, so PHP WordPress or PHP October CMS. It really depends on what it is that you wish to do. The thing with WordPress is that clients love it. They absolutely adore it because it's so easy for them to use. It's full of WYSIWYG editors that you can go from one company to another company and you just know it, right? So clients that I've had, they have people that come in to do content, to do copy using WordPress. That's one of the first questions they ask is, do you know WordPress? Yes, good, okay. October CMS, Concrete 5, there's loads of other ones. They are great. However, they have their own way of doing things. They have their own way of creating blocks and pages and plugins and all of that kind of stuff. WordPress being the sort of de facto content management system for microsites, it seems, from my perspective, from my point of view, from my experience with working with clients that have lots of micro sites, they tend to use WordPress simply because they can get WordPress, they can get people quicker on board because they know WordPress. Now that certainly doesn't talk about the technical sides of WordPress or October CMS or Concrete 5 or any kind of bespoke thing at all. That is just from the point of view of getting bums on seats to actually write your copy. If you have to train someone up in order to do bits and pieces on an application, to create a menu, to create a page, to create a blog post, to create an article, then that becomes a barrier. And because WordPress is this, as I said, the de facto standard, because there's so many, it's just easy to install, it's easy to use. You're constantly fighting that struggle. The thing is, WordPress, I mean, I've created lots of WordPress sites and I've created lots of WordPress plugins as well. I don't necessarily like WordPress. I'm not the biggest fan of WordPress. It's not coded in a way that I particularly enjoy to work with. So there is that. There is a bit of a pushback from developers who use WordPress that I know of because they have to adhere to the WordPress way. So the massive loops and the crazy naming conventions and the database is not configured in a way that seems very logical. Personally, I tend to use a lot of bespoke stuff. I'm at the moment a Symfony and Laravel developer. I do a lot of Symfony work. I do a lot of Laravel work. Luckily, Symfony and Laravel they're quite similar. They're quite similar. In fact, Laravel uses a lot of components of Symfony because Symfony has modularized itself. So the way in which perhaps the requests and the responses are handled in the controller of Laravel is much similar, very similar to the way it's done in Symfony, because it's using the Symfony components of Laravel. For a developer, just check out the composer.json file and see all of the stuff that Laravel has to include to actually get Laravel installed, and then compare that to all of the stuff in Symfony to get Symfony installed. Essentially, what these frameworks differ is the sugar on top, the stuff that is on top, the stuff that handles the responses and the requests, that handles the communication between the services, and so forth. But the actual grunt work, the real nitty gritty foundations, they are very standardized these days, and you have these things like the PSR standards that these frameworks are adhering to and following, because standards are good and standards make more contribution, because when you're following a standard, you're following the same standard that everyone else is following, and therefore it's easier to work with and easier to maintain. Going back to the refactoring there, and when you're dealing with that, it's very easy to switch from one to the two. There is also Concrete 5. Concrete 5 is like the way of it's very similar to WordPress in the sense that it's very WYSIWYG editor. It's a content management system after all, but it's built on a lot of the Symfony components. So I think really there is the I think the argument is which, from a point of view of what developer would you be, a October CMS guy or a Concrete 5 guy? It's take away all the fluff, take away all the stuff that you have to go through in order to create a page, create a menu, and all of that stuff. None of that matters from a developer's point of view. It's all about what are the components that are being used, what's the framework underneath, what is the what are the libraries that are in use, how easy it is for me to add a plugin to this thing. And one thing that crops up hugely is how much of a roadmap do I know right now, because there is so many times where I've just heard clients or developers of clients go, yeah, we tried to do this, but then they updated their application and we weren't aware that they updated their application, and so we can't do this anymore because we've had to do this in a completely different fashion, a completely different way, and it's broken the stuff that we tried to do bespokely earlier. Now, there's been a lot of times where I've actually taken a WordPress site and I've turned it into either Laravel or Symfony, because the things that the clients were asking and the roadmap of the client just didn't feel right with the frameworks, with the content management system. You are giving over a lot of control to the maintainers and developers of those things. And so if they change the way a plugin works, then you as a developer have to maintain that and change that and work with that and run with that. And so you are giving a lot of your control over. And there's been lots of times where, especially with WordPress is just so, I just think it's just the way in which you can allow a client to update WordPress by pulling down a zip file or a compressed file and then updating the data. That's just dangerous. That is just so dangerous. So that gets turned off. If they need to update WordPress, they come to the developer. They don't just update it on themselves, because as soon as you start writing custom code, then you need to ensure that that custom code that you've created still works with the updates. And because you're not aware of the updates coming through, yes, you might be able to go through and read the roadmap and so on and so forth. But really, you want to be in control of that. So as a developer, I really do ask the clients what is their roadmap, because you don't want to, if for example 1 year they want to have a blog and the next year they want to have an e-commerce shopping cart, and then the following year they want to have a stock management system, and then the following year they want something else and they want something else. You need to make sure that whatever foundation work that you're putting down now allows you to do those kind of things. I've now just turned that question into a massive rant, and I do apologize. And I don't think I've actually answered it. What do you recommend, PHP WordPress or PHP October CMS? It's very tricky to say what I recommend. From a developer's point of view, I recommend something that is fairly bespoke. And if they only want something that is incredibly simple, then just use a micro framework. Just use something like Slim PHP or Lumen, which is Laravel's micro framework, because then that is easier for you to maintain as a developer. Yes, you need to put in all the fluff and stuff, and this is all the attractive stuff from a client's point of view, but I look upon it from a developer's point of view and a client's point of view. Yeah, there's some interesting topics around that. I might talk about this more in a bigger video later on. But thanks ever so much, DIY coders, for that question. It was a very good one, and I apologize for the long rant. So we're now hitting the hour mark. I'm going to shoot off because I'm actually going to go out for a run tonight. I think it is getting a bit dark, so I'll probably have to put lights on. But hey. Thank you ever so much for watching. If you haven't done so already, please do subscribe, because like I said, Tuesdays we do a tutorial, and on the Fridays I do a discussion, and Wednesdays we do a similar talk like this. Before I go though, I just want to mention that there is a sale at the moment at Apress. Apress is a great publication company that does a lot of books for programming. They have a 40% off sale at the moment. What I'll do is I'll just put this in the old chat. Put that in. Where's the chat gone? Here. Let's paste that in. Paste in like so. There we go. So there is a link there to Apress for, they've got lots of Java books. They've got lots of database books. It's a 40% sale off, and it finishes, excuse me, at the end of this month. It's a Halloween sale. And there is also another one that I would like to share with you all. This is 49% off. 49% off SSL certificates from a company called Namecheap. Let's just put that back in here too. So I'll just put that into the chat. So that's 49% off SSL certificates. I must say these are affiliate links, so I will get a kickback from that too, which I certainly do appreciate. But thanks ever so much for watching. Happy coding, everyone. I'll see you again soon, and just have a good week. Cheers. Bye.